According to the National Electrical Code, panels in a multi-dwelling unit can be fed from meters passing through another dwelling as long as certain conditions are met. These conditions primarily focus on ensuring safety and preventing electrical hazards. These conditions are detailed in the following manner. Firstly, conductors must be insulated and protected. The conductors supplying the panels need to be insulated to prevent electrical shorts and ground faults. They also must be protected from physical damage throughout their entire length. This means safeguarding them against impacts, abrasions, and other potential hazards that could compromise their insulation. Approved methods for achieving this protection include using conduit, wireways, or other protective enclosures that meet the relevant safety standards. Conduit, for instance, provides a robust physical barrier against damage, while wireways offer a more flexible solution for routing and protecting multiple conductors. The choice of protection method depends on the specific installation environment and the level of protection required. Secondly, conductors must be properly sized. The size of the conductors must be adequate to handle the current draw of the panels and any other connected loads. This is crucial to prevent overheating and potential fire hazards. The conductor size is determined by the ampacity, which is the maximum current a conductor can carry continuously under specified conditions without exceeding its temperature rating. The National Electrical Code provides tables and guidelines for determining the appropriate conductor size based on the expected load and other factors such as the ambient temperature and the type of insulation. Using undersized conductors can lead to voltage drop, inefficient operation, and even insulation failure. Thirdly, overcurrent protection must be provided. Overcurrent devices, such as circuit breakers or fuses, must be installed to protect the conductors and equipment from damage in the event of an electrical overload or fault. These devices are designed to automatically interrupt the flow of current when it exceeds a predetermined level, preventing damage to the wiring and equipment. Circuit breakers can be reset after tripping, while fuses must be replaced. The overcurrent protection devices must be properly sized to match the ampacity of the conductors they are protecting. This ensures that they will trip or blow before the conductors are overloaded. Fourthly, grounding must be provided. A grounding system must be provided to protect the panels and equipment from electrical shock. Grounding provides a low impedance path for fault current to flow back to the source, causing the overcurrent protection device to trip and de-energize the circuit. This helps to prevent electrical shock hazards by ensuring that exposed metal parts of the equipment are at ground potential. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, connected to the electrical panel and the equipment grounding conductors. These conductors provide a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock. Fifthly, access must be provided. Access must be provided to the panels and overcurrent devices for servicing and maintenance. This is essential for ensuring that qualified personnel can safely inspect, test, and repair the electrical system. The panels and overcurrent devices should be located in a readily accessible location free from obstructions. Sufficient working space should be provided around the equipment to allow for safe and efficient maintenance. In addition to these specific requirements, it's important to note that running conductors underground or encasing them in concrete is not always required. However, if the conductors pass through a damp or wet area or are exposed to physical damage, additional protection may be necessary. This could include using waterproof conduit or encasing the conductors in concrete to provide additional physical protection. The specific requirements for conductor protection depend on the environment in which the conductors are installed and the potential risks they may be exposed to. Ultimately, compliance with the National Electrical Code is essential for ensuring the safety and reliability of electrical installations in multi-dwelling units. It is always recommended to consult with a qualified electrician to ensure that the installation meets all applicable codes and standards. When considering electrical installations in multi-dwelling units, it is crucial to understand the specific requirements outlined in the National Electrical Code (NEC) to ensure safety and compliance. The NEC provides detailed guidelines on how electrical systems should be designed, installed, and maintained to minimize the risk of electrical hazards. Firstly, the NEC addresses the issue of conductors passing through other dwelling units. While it is permissible to run conductors from meters through other dwelling units to feed panels, it is subject to stringent conditions to safeguard residents and prevent potential electrical problems. These conditions ensure that the electrical system is robust, well protected, and accessible for maintenance. Secondly, insulation and protection of conductors are paramount. The NEC mandates that conductors supplying panels must be adequately insulated and protected from physical damage throughout their entire length. This is typically achieved by encasing the conductors in conduit, wireways, or other approved protective methods. Conduit, for example, provides a rigid, non-combustible barrier that shields the conductors from impacts, moisture, and other environmental factors. Wireways offer a more flexible solution for routing conductors, especially in complex or confined spaces. The choice of protection method depends on the specific installation conditions and the level of protection required. Thirdly, proper sizing of conductors is essential. The NEC emphasizes the importance of sizing conductors appropriately to handle the current draw of the panels and any connected loads. Undersized conductors can overheat, leading to insulation breakdown, voltage drop, and potentially even fires. The NEC provides detailed tables and calculations to determine the correct conductor size based on the expected load, ambient temperature, and other relevant factors. These calculations take into account the ampacity of the conductors, which is the maximum current they can safely carry without exceeding their temperature rating. Fourthly, overcurrent protection is a critical safety measure. The NEC requires the installation of overcurrent devices, such as circuit breakers or fuses, to protect conductors and equipment from damage due to electrical overloads or faults. These devices are designed to automatically interrupt the flow of current when it exceeds a predetermined level, preventing overheating, insulation damage, and potential fires. Circuit breakers are resettable and can be used repeatedly, while fuses must be replaced after they blow. The overcurrent protection devices must be properly sized to match the ampacity of the conductors they are protecting, ensuring that they trip or blow before the conductors are overloaded. Fifthly, grounding is a fundamental safety requirement. The NEC mandates that a grounding system be provided to protect panels and equipment from electrical shock. Grounding creates a low impedance path for fault current to flow back to the source, causing the overcurrent protection device to trip and de-energize the circuit. This helps to prevent electrical shock hazards by ensuring that exposed metal parts of the equipment are at ground potential. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, connected to the electrical panel and the equipment grounding conductors. Sixthly, accessibility for servicing and maintenance is crucial. The NEC requires that access be provided to the panels and overcurrent devices for servicing and maintenance. This ensures that qualified personnel can safely inspect, test, and repair the electrical system. The panels and overcurrent devices should be located in readily accessible locations, free from obstructions. Sufficient working space should be provided around the equipment to allow for safe and efficient maintenance. It's important to note that while the NEC does not always require conductors to be run underground or encased in concrete, additional protection may be necessary in certain situations. For example, if the conductors pass through a damp or wet area or are exposed to physical damage, they may need to be encased in waterproof conduit or concrete to provide additional protection. The specific requirements for conductor protection depend on the environment in which the conductors are installed and the potential risks they may be exposed to. Moreover, certain sections of the NEC, such as Article 310.15, provide detailed guidelines for determining the ampacity of conductors under various conditions. This information is essential for selecting the correct conductor size to ensure safe and reliable operation of the electrical system. Other relevant articles, such as 230.7t, address the location and accessibility of service disconnects, which are critical for isolating the electrical system in case of an emergency. Compliance with these and other applicable sections of the NEC is essential for ensuring the safety and reliability of electrical installations in multi-dwelling units. The NEC also addresses the use of approved materials and equipment. All electrical components used in the installation must be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, all to ensure that they meet safety standards. This includes conductors, conduit, wireways, overcurrent devices, and other electrical equipment. The use of unapproved or counterfeit electrical components can create serious safety hazards and should be avoided at all costs. Furthermore, the NEC requires that all electrical work be performed by qualified personnel. This means that electricians and other electrical workers must be properly trained and licensed to perform electrical installations. Unqualified individuals should not attempt to perform electrical work, as this can create dangerous situations and potentially violate the NEC. Regular inspections are also essential for maintaining the safety and reliability of electrical systems in multi-dwelling units. The NEC recommends that electrical systems be inspected periodically by qualified electrical inspectors to identify any potential hazards or code violations. These inspections can help to prevent electrical fires, shocks, and other electrical accidents. In summary, the NEC provides comprehensive guidelines for electrical installations in multi-dwelling units to ensure safety and compliance. By following these guidelines, electrical systems can be designed, installed, and maintained to minimize the risk of electrical hazards and protect residents from potential harm. It is always recommended to consult with a qualified electrician to ensure that the installation meets all applicable codes and standards. Regarding specific NEC sections that might be relevant, consider the following. NEC Article 225 covers outside branch circuits and feeders, which may apply if the conductors are run outside the building. NEC Article 230 deals with services, which is relevant to the service entrance conductors and equipment. NEC Article 240 covers overcurrent protection, which is crucial for protecting conductors and equipment from overloads and short circuits. NEC Article 250 covers grounding and bonding, which is essential for safety and preventing electrical shock hazards. NEC Article 300 covers wiring methods, which provides general requirements for installing conductors and raceways. NEC Article 310 covers conductors for general wiring, including ampacity calculations and insulation requirements. And finally, NEC Article 314 covers outlet boxes, device boxes, pull boxes, and junction boxes, which are used to terminate and protect conductors. These are just a few of the many NEC articles that may be relevant to electrical installations in multi-dwelling units. It is important to consult the NEC directly to ensure that all applicable requirements are met. In addition to the NEC, local codes and regulations may also apply. These codes may be more stringent than the NEC and may address specific local conditions or concerns. It is important to check with the local building department or electrical inspector to determine what codes and regulations apply to the specific installation. Finally, it is important to remember that electrical work can be dangerous. Always take precautions to protect yourself from electrical shock and other hazards. To energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. If you are not qualified to perform electrical work, hire a licensed electrician to do the job.